Okay. Well, hello, everybody. Thank you so much for your time. Thank you so much for coming today to listen to Ibra today in regards to, and his name is Ibrea Kosso, and we're going to be listening to him. He's our student, a graduate of Miga Ndede's Advanced Python class. Today, Ibra is going to be talking to us about the Bitcoin price prediction using data science and machine learning. So guys, thank you for your time. Thank you for coming. Feel free to ask questions after the fact. Ibra is going to give you his presentation and run through the prediction of Bitcoin using data science and machine learning, and then go through that. And then at the end, you have time to ask any questions. So Ibra, over to you.
Okay, thank you very much, Jackie. It's such an honor to have this presentation and to have this information, this presentation passed to the rest of you. So as Jackie has already said, my present topic, my project topic is about Bitcoin market prediction. So first of all, what's Bitcoin? So Bitcoin is currently one of the cryptocurrency form of money that is in existence, that is one of the most famous one amongst many others in the world today. This has been established in 2019, but since 2013 is when Bitcoin became operational and got so famous. So what I'm doing is Bitcoin price prediction using data science and machine learning. So ever since the Bitcoin has come to the market, this is a new form of currency which has been built on blockchain technology, one of the current emerging technologies that uses a form of distributed ledger. So Bitcoin is more of a categorized as a commodity more than a currency. So and ever since, the prices of Bitcoin has been fluctuating, going up and down. And since this is a new venture, a new thing that has been brought to the market, making a prediction of or doing a prediction that in a way helps in predicting or forecasting the future prices of this will be one of the most encouraged and important areas for both traders and for both the investors. So that is fine. I will found it towards to have this in my project and thought of it as making a prediction about it. So to start, I don't know if I'm sharing my screen.
So you have the privileges, right? You'll be sharing your screen.
Yeah, you should have.
Yes, thank you.
Yeah, put on make sure it's on display so you can do the slide. Yeah, that's good.
Yes. So yeah, so Bitcoin price prediction using data science and machine learning. So as I already explained earlier, Bitcoin market prediction is act of trying to determine the future value of a Bitcoin or the financial instrument that is currently traded on an exchange market. So making a successful prediction of the future prices of Bitcoin prices is one of the areas that will be very beneficial for the investors and the traders, since this is one of the most valued and current form of cryptocurrency in today's world. And considering that the market capitalization of this commodity has gone so much high since May 2013 to one of the highest values compared to any other form of cryptocurrency. So just before I talk of what I did or how I go by making a prediction of these Bitcoin prices, let me first give you an overview of what data science is and what machine learning is and how these two concepts are both incorporated to have this project a success. So in today's world, as we all know, we are welcoming the fourth industrial revolution with intelligent technologies and new technologies such as artificial intelligence, Internet of Things, and 5G. These are one of the things that are currently going on. And all these are geared to make a difference and different, making life easy and to drive changes in both global and economical trends, both in the world and in the current situation in the society level. So that said, the machine learning and data science concept that I have incorporated in my topic that you see is one of the things that goes in under the artificial intelligence as a new technical science that studies and develops theory. So first, what is an artificial intelligence? So artificial intelligence, this is in one simple word, is to make machines think, an ability to make a machine think. So, and since its evolution of the AI up to now, AI has gone through multiple stages, from weak AI to strong AI. So where basically weak AI, it's just meant to do some basic or simple tasks. Machines are just meant to complete simple basic tasks. Whereas the strong form of AI now, it is where the computers are made to think or act rationally or think like humans. So they are made to have a conscious, they are made to have a prediction, make a prediction, and they are made to infer and do things just like human brain. So it's made to mimic human activity. So just to give you an overview, there are multiple forms of intelligences, even in our day-to-day life. You can think of verbal or linguistic intelligence, logical, visual, musical, interpersonal. So I have listed a number of them here, but not to spend much time on this, let me proceed to the key concept of the project. So most of these things from in artificial intelligence, there are a number of concepts that are intertwined to be working together and form some kind of a set like the one I'm showing you here. So the concept of artificial intelligence and data science and all the rest in technology, it's a form of one thing is buying or acquiring a concept from the other. And most of the things are what I've displayed here in a set, from statistics to pattern recognition, artificial intelligence, machine learning, data mining. Data mining is one of the most key important of all these, where each and every other concept you see here is a way connected to data mining, databases, KDD, and the rest. So to give you an overview of how AI, machine learning, and deep learning are interconnected, you can see an overview structure here that gives us an impression of what these are like. So artificial intelligence, machine learning, and deep learning. As I said earlier, artificial intelligence is, in simple terms, is enabling machine to think. So machine learning now, it's one of the core areas of the artificial intelligence, whereby computers are trained to make decisions, to learn, and make a decision at the end of the day from what you feed, from how you do. So categorically, they are divided to supervised form of machine learning and supervised form of machine learning, reinforcement learning, and many others. But in one word, this is training of computers to make a decision. And the deep learning now, it's more contextual. It's a subset of machine learning whereby computers are made to mimic the human brain. So this one is a bit more advanced stage in such a way that this involves more neurons and more layers of functions and processes, such that it's an advanced context of machine learning. It takes the best example of human brain. How human brain works is what we are trying to incorporate to computers now at the deep learning level. So, and that is how all of these things are connected to each other. And the bigger one now, the bigger concept of the mother of all this is artificial intelligence. Because at the end of the day, the goal is to come up with an application that does what human being does. So first now to start with, since my project is basically based on machine learning, what is machine learning? Including the planning. It's a study of learning algorithms. A computer program, sorry.
That will not happen on the day, right?
All right.
Okay.
So it's the study of learning algorithms. A computer program is fed with set of data set. Then the computer, they acquire an experience from the data that you feed. This is an activity With respect to this now, it's able to solve some other tasks differently, and you are able to measure the performance of this computer out of the tasks that it does. And remember, the computer is able to do this task based on the experiences that it had acquired learning from the data, a particular data set. So thus, you can say a machine learning is process of now you fit a function to an example and use that particular function to generalize and make prediction about new examples. Now that you have fitted a machine learning algorithm to a particular set of data which takes a particular pattern, it's able to learn, it's able to acquire an experience whereby you will be able to fit this algorithm now into a different set of data and be able to make a prediction based on the experiences that it has acquired from the previous one. So, and this is basically the structure of what this is about. The data is now the experience. Learning algorithm is now the function, the method. And then finally, basic understanding. What has this method, algorithm understood from that data set? How do you measure its performance after having acquired this experience to make future prediction or to make future forecasting and helping you in what you best what to achieve? So machine learning system should process a sample and a sample of features that have been quantitatively measured from some areas or from some event that we want the machine learning system to process. So this can either be, first of all, I think this machine problem, it can either be a classification problem, a regression problem. So a classification is where a particular data is in such a way that you can either classify it to be one thing or the other. Specifically, either if you classify maybe this as true or false. So after a particular series of features, you can either say this thing is true or you can say this thing is false, or you can say this thing goes into A or B. So alternatively, it can be true and it cannot be anything else in between. A regression now is whereby the target data is in the format of continuous values. So each and every particular feature goes into a particular target. Can be the same, but can be as well. All of them are uniquely different. So this has some sense of continuous values. So basically in today's world, what are the scenarios of machine learning? So the most common scenarios of machine learning, categorically, it can be handwritten rules and equations that are too complex, as in terms of maybe a face recognition, a speech recognition, one sector, and also in the areas of fraud detection, like in transactional records and so on. And also when we are dealing with the nature of data that keeps changing. So for instance, making an automated trading, energy demand forecasting, and predicting shopping trades. So now this is where our Bitcoin price prediction comes in. So basically the Bitcoin price prediction is a use case that we are using for this to explain what machine learning and data science can be able to achieve. Machine learning process, there is a process in making the machines learn. So this is an entirely process that gradually builds from one to other and finally as displayed here. So the first step is the data collection. Where does this machine learn from? That's the big question. What is data? That's another one. So a data is a collection of records or information that has been acquired from multiple places or different areas, gathered together, stored together for use. So in our case here, when we talk of Bitcoin price prediction, this price prediction is entirely based on the previous prices of Bitcoin as it is in the market. So we can acquire this data from different areas, but use based on that particular data, what are we able to acquire? In short, we are making use of this data to benefit, to make a future forecasting. So first stage is collecting the data. You have to have that data collected, and then that is the first stage. Data cleansing is another stage. That is where now you extract anything, features or noise or missing values, or you cleanse your data in such a way that it is in the format that you want to have for this project or whatever it is that you want to do. feature extraction and selection, model training, model evaluation, and model deployment. So I will be explaining each and every of these as practically in my project as we'll be proceeding. But just to give you an overview, this is the stages that are involved in machine learning process. So data set. So data is a collection of data that is used in machine learning tasks. So the data is a sample that represents the prices of Bitcoin. For our case now, the prices of Bitcoin or information associated with Bitcoin, but we will explore this data as we continue. So for machine learning, the data is broken down. After you have done whatever you do, the data is broken down into training set and test set. So the training set is a data that is used in training the process, where each sample is referred to as training sample. And the test set is the data now that you use to test if your machine is able to learn and make the accurate prediction, the performance of the machine. So for our Bitcoin, first, as I said, the first stage in machine learning process is collection of data. So for this case, the data that I have used for this particular project, I have acquired it from Yahoo. This is the link to that data. That is where I downloaded this data from. And then I was able to download the data in form of a CSV form. So here you can have an overview of what this data set looks like. This is the raw data. I haven't done anything in Excel. So just after I've downloaded the CSV file, it is in this format. So you could have a picture of what that data set looks like. So the date, the prices of the Bitcoin, the highs, the opening prices, the lowest price, the closing price, the volume, and the market capitalization. So this is how that data set looks. The raw data set view of the raw data set. This is how it is. So, and this is the data that you are going to work with, to build on, and use in achieving what you want to achieve. So the tools used for this project, the programming language that I used is Python. The integrated development IDE environment is the Jupyter Notebook, data visualization, Matplotlib, and Seaborn. So the first stage in this process, what I did is I had to upload the draw data into the pandas data frame. So the IDE is an integrated development environment whereby you will be able to use to work in, use your data and do everything that you want to do here. So the data is in Excel CSV form. I uploaded the data to the pandas data frame using this command, and this is now the structure of the data after uploaded to the Python integrated development environment. So first and foremost, before we could do anything to our data set, here is the visualization of data. So I just plotted this data into a graph, and so that you can have a view of a structure of how this data looks like. So the column I use is the closing prices. I plotted a graph of the Bitcoin closing prices for the last 5 years. And the structure is as shown here. So I had plotted two lines, whereby one, the blue one is daily close prices. So the Bitcoin prices from 2016, day one, up to the 2020 until then, for the last 5 years, each and every day prices is now shown graphically here, as you can see. Now that's the blue value. That's why the structure of the line is quite different. And the red one is now, what I did is that I calculated the monthly average close prices of Bitcoin for the last 5 years. So this one is quite a straight, smoother line. That's why you could see for every month you have only one value, unlike the other one will be having 30 values or so. So just to give you an overview of the trend of Bitcoin prices over these 5 years, you could have a view of what it is and how the trend has been going. So before you could do anything with the data. So I hope you could see from 2016, the trend of Bitcoin prices up to 2020, how it's going up and down and multiple inflations. Data pre-processing. Now, this is now the most and the basic key process in machine learning. You have to pre-process your data. You can have this data in different formats, in multiple formats, but now how you are going to make use of this data and reveal the most usable insight entirely depends on what you are going to do on this data. You have to explore your data, you have to understand your data, you have to know what you want, the features that you want for this, for whatever you want to do, and you'll be able to extract the features that you need for this. And as well, it's important for you to explore your data so that you will know what to make use of and what not. And even when you talk of machine learning algorithms, there are multiple algorithms. So depending on the structure of your data, your data type and everything, you will be able to figure out which machine learning algorithms works best for this particular form of data. So when we talk of data preprocessing, entirely data preprocessing is all about data cleansing. Data cleansing could be filling in the missing values. You detect or eliminate the causes of maybe the dataset exemptions. If there is any missing value, if there is any different data type value that could be maybe placed erroneously or any form of outliers, so you will be able to explore your data, analyze your data row by row, column by column, and then you do the decleansing first. Data preprocessing, also dimension reduction. Maybe when you download this data from a particular website, it comes in with different dimensions. You might be having like 12 columns, 13 columns, and then maybe and what you need is around 4 to 3 columns, or even 2 or 1. So you don't need to work with the entire data set. You just pull or extract the features that you would want for your particular project and work with it. That is the dimension reduction. Data normalization also. So when we talk of data, like the one we see, it is in form of rows and columns. Remember, there are values there, and the values can come in different range. You might be having a range for, like if you have values like age, the age value probably it ranges from, it can be more than 100, let's say. But then you have a prices column. So these two columns are working together, and the prices could be values like million, thousand, hundreds. So working with these two different values that are absolutely apart could be problem. It's not the best fit when you're working with machine learning algorithms. So you have to work for look for a way you can normalize these data values to reduce the noise, and also it's one way that to improve your model accuracy. Feature cleansing and feature collection. And then I have explained much about this. When you cleanse your data, you pre-process lost data, you see if there is any possible exception, errors, or even abnormal values in your data set, and you're able to fix this before you work with your data. If it's in any way you will need to combine data from different sources, at this stage is when you have the opportunity to do this and come up with a composite data set that includes everything that is needed for your project. So generally, a dataset can have many features. Others are needed and others are irrelevant. So data cleansing and feature selection is when you pull what you need and discard the rest. So I've explained this, and the importance of doing feature selection. First, it reduces the training time of your model. It simplifies even your model to make it easy for users to interpret. When you are dealing with a dataset that has only particular needed rows and columns, this could be even for a novice who doesn't understand what's going on. It's easy to go through, to analyze and find out, even to explain to them. It could be better with a small and concise data set. It is another advantage is also avoid dimension explosion, improve model generalization, and avoid overfitting. We will talk about model generalization and overfitting as we proceed to the next stage. So here at this stage, with my data set, what I try to do is first, I was checking if there is any values in that data set, any null values in the data set. So here, the first one here is all the columns for our data set. The open, whereby open is the opening prices of Bitcoin, the highest recorded price of the Bitcoin, the lowest, the closing prices, the value, and the market capitalization. for which there is no any non-value in our dataset. So we have false for all of them. So which means there is no any null value or missing value in our dataset. Second here is dimension reduction, that is a form of feature selection. In this case, we are having a dataset with 6 columns, that is 6 features. But for my project, what I want to do is price prediction, and the only thing I wanted to deal with is the prices of Bitcoin over time. So I don't need the volume, I don't need the market capitalization. So from my dataset, I drop these 2 columns so that I'll be remaining with only 4 of them. So after dropping, this is the structure of the data. So this is the structure of the data that we'll be dealing with for the rest of my project. So when we talk of feature selection or dimension reduction, is now this is what you can see here. Outlier treatment. So for my data set, this is what I wanted to add on, but there is no any outliers. We could go back to our
you wanna
notebook. Yeah? Yes.
correct the spelling on the techniques. Yes. On one of the slides,
yes,
the word technique is misspelled. Yeah, that one. Go to that slide.
Yeah. So this is actually just before I started the presentation. This is what I added, but I have done it from my panel, my model. So when we talk of outliers, outliers is any abnormal value in that particular data set, any number that goes out of the range, explicitly out of the range. So there is the maximum limit or the lowest limit to which the range can go, the quartiles. So from the knowledge of statistics, we have quartiles, the highest quartile, the first, second, fourth, and so. So any number that goes out of the range, maybe out of the 21st quartile or of the highest range of the values, that is what we call outliers, the abnormal values. So these outliers could be erroneously made by the person who has been filling the dataset, or it can be, yes, true, it happened. So for instance, when we are having values like data features like age, so the ages of individuals could be ranging from maybe, let's say 20, 40, 50, somewhere there for that particular data set. And then you have a case whereby a particular age is 180 years. So we don't know, we know, obviously nobody can go to 180 years, that doesn't make sense. So maybe this could be an error to say this person is 18 years, but by mistake, the person has wrote it 180. Or maybe a case whereby as someone age goes beyond 0, you have a negative value, for instance, -10. Nobody's age can be -10. So this could be erroneous. So in this case, we need to clean and remove all these outliers and make sure our data set is in the structure that is sensible before we do model training and stuff. So when we talk of outliers, that is what outliers are. So for my case here, so first, I looked at the shape of the data. So I had 2063 rows for each columns, open, high, close, low, all of them of 2063. There are no null values. So here, there's a describe method in Python whereby you will be able to see the mean, the standard, the 25th quartile to 75th quartile. So anything that goes way much beyond the bare minimum or the maximum value recorded for that particular feature can be considered an outlier. For which, going through this one, we do not have any outliers because the values are all of them are in range. If you observe closely your data set, I do not have any values outside this range. So when you identify the outliers, I try to figure out if there is any number that is explicitly way outside or way above the values recorded. And here, we can see there is no any value that is completely outside the range. So we do not have an outlier in our data set. The next, dimension expansion. Here is now dimension expansion is adding extra dimension or adding extra features to our existing data set. So adding an extra feature here, you can use an average, you can use a mean, you can use any other means that you could use to add an extra feature or attribute for this data set. Here, what I added is the average value. Remember, we have the opening prices, the highest, the lowest, and the closing prices. So I made an average of all these from opening for maybe for this particular date, 25th of April, the first one. I was finding an average of the entire data set, whereby you add all this and you divide by the number of features. So we have an extra column by name average. So this is like a new feature we have added to our data set that has not been existing before. So adding a new feature, data dimension, is also one of the important areas in data science, because when training your model, the more features, more reliable features that you have, the more accurate your model will be. So I thought of adding this one could be important in this process. So the next process is data preparation. So here, what I did is, now that I have my data set, data cleansing and data preprocessing I've had, what I'm doing now is that I have to prepare my data to fit to our model for building the model, the machine learning model. So first, in this case, you have to separate your data into attributes and labels, whereby attributes are the independent variables. Here we have X and Y variables basically, because machine learning is a machine learning algorithm is an algorithm. It's something that works on a function. So it's a mathematical statistical function, whereby now we will be fitting our data set to a form of a function that a computer does for a library does for us. So before we continue to discuss this much further, but at this particular point, I separated my data set to attributes and labels. So for our case here, all my features that I have are the attributes, are the features. And the label is the target. What target would you want to achieve? So for this case here, I created a target for my data set. And the target I created is price after 2 weeks. So using all those features, the prices of this Bitcoin, I want to make a prediction of the price of Bitcoin maybe after 2 weeks. So I created a new feature called a label called price after 2 weeks. So a price after 2 weeks is whereby now using the closing prices of the Bitcoin from the closing column, now I made a shift of 15, like negative 15. So that's the shift function now has the capability, if in Python, to shift the prices of this using the values from the close column. We'll be able to create a new other column called price after 2 weeks, whereby the values are based on how you will work with the command. So the method I used is the shift method, whereby the values are shifted 15 values next after every 2 weeks, after every 2 weeks. That is basically literally what it does. So after having done this, you could see we have a new column here, price after 2 weeks, that has been created. So in this case, the price after 2 weeks, this is the column that we'll be using for as our labels, and the rest 5 columns are our features, attributes of our data set. And this on this other side now this is where I separated the train, the X train, X test, Y train, and Y test. The train test is the data set whereby we will train our model on, and the test set is the set whereby we will be using these values to test if our model makes a correct prediction, having learned from the training set. So I splitted this data into train and the test set. So the output of the train and the test set, because I used the test size of the test data as 20% of the data to be used for testing, and then 80% to be used for training. So you can see the structure of the data as it is now. The value of the X train is 1,638 rows, and it is the 5 column. And then the Y train is 1,638. I mean, you can see. So this is 1,638 is 80% of our entire data set, which was around 2,063 observations. So after splitting our data now, we have to choose which model are we going to use for this particular project. So before I talk of the model that I've used, there is an overview of what machine algorithm is. In machine algorithm, machine learning is majorly divided as supervised and unsupervised learning. There is also reinforcement learning, but the major ones are supervised and unsupervised learning, the ones that we'll be discussing for this. If we talk of supervised, this is where the data, there is a data that is involved in this process. So machines are trained using a particular data set. So they learn from a data set so that it will be able to make predictions. In an unsupervised learning, there is no data that is involved. Machines, they are not trained. It's like, so the training is like teaching the machines. So the data set is not involved, the machines are not trained. So for the supervised learning, we have both classification and regression problem. So I had said what the classification is and what the regression is. So these are the machine learning algorithms that we have for classification, and these are the machine learning algorithms that we have for regression problem. So, and actually there are some of these algorithms which are really powerful that can be used both for classification and both for regression, depending on the parameters and the hyperparameters that we will be going to choose. So like SVM. SVM can be used both for classification and regression. Neural network, yes, decision tree, random forest, and yeah, these are the list. I hope you could see what these are. So for my project, in our case here, the models that I used are all entirely supervised learning. And these are the 3 models that I trained for this project. So I used linear regression, I used a port vector machine, and I also used random forest. First, before you talk of you saying which algorithm am I going to use, I say the understand exploration of your data is one of the key areas. You have to understand the form, the structure of your data set. You have to explore your data and understand what it is in your data set. So for our case, we have gone through our data. We have large amount of data, yeah, and then we have prices of Bitcoin. So you see the highest price, the lowest price, the opening price, and the whole prices. And then we have the targets that we want to achieve. The target that we set for this is the price after. So we have a label, right? So from the data that we've seen, we are dealing with a time series that are values that are randomly interchanging. So a continuous value. And our target, it's not in any way, it's not a classification problem, it's a regression problem. For one, so before you talk of using any machine learning, you have to know if it's a classification problem or if it's a regression problem. And yes, for our case, it's a regression problem because we are dealing with continuous values of 2,063 observations. So in this case, I used, yes, I used a supervised learning method. So our goal is to build now a model that infinitely expresses true distribution of this data set and make a future prediction of unknown Bitcoin prices using the prices over those range of years. So this is a procedure of building a model. First, you have to select your data, you have to split your data, you have to divide your data into training and the test set, of which, yes, we did. Next, you have to model the data, you have to build the model. So using the training data, we'll build the model using the relevant features that you have for your data set. The validation model, this is a process now, you access the model with your validation data set. If you have split the data, your data set as training, test, and validation. The test model, the fourth stage is now you check the performance of your model using the data set, the test set of data. So you test if your model accuracy, the accuracy of your model, and how accurate your model can be able to make predictions for the Bitcoin prices. Finally, you deploy the model. Now, after you train your model, you can save your model and maybe in the market to be used maybe by investors or whatever. So in this case now, the trained model can be able to make prediction. Now that is what actually the goal of machine learning, to make a model that can make a prediction for the Bitcoin prices in this case. Then finally, you can tune your model. You can improve the performance of your model with more data, with different features, with adjusted hyperparameters, and so on. So as you go gradually, you can build on to improve the model accuracy by incorporating a valid model. So as I said earlier, I used three models: linear regression, support vector machine, and the random forest. So to start with, the first model, here linear approach to modeling. The independent variable are the features, are the attributes of your dataset, the dependent variable. And then the independent one now are the features, are the attributes of your data, and dependent variable are the targets now. So X and Y, in our case, what we have. So here, the linear regression now, just to give you a view of how linear regression works, is we are trying to fit our data set on a straight line. So from this straight line, we'll be able to identify what goes in where. So the data set is fit on a straight line, and along this straight line, it will be able, the machine is able to tell and make prediction from the values, the features. So the first stage here, we have one of the libraries, we release library, sklearn. We, from the sklearn.linear model, that is a class in sklearn, we'll be able to import linear regression. And then here, regressor.fit now is when now at this the stage now whereby we are using our dataset, our trained dataset to fit into to fit our model into this dataset. So you remember we have splitted our data both X-train, Y-train, X-test, and Y-test. So when we say fitting the model, now that is where you are building your model so that it will be able to learn from this trained data. So after the machine has been fit, after the model has been fitted to this data set, it's able to learn from this experience and make predictions now. So after fitting our model, the next here, you can see now I was trying to test the accuracy of the linear regression based on the data set that I fed. So here you can see the accuracy of linear regression is at 86.56. Now the next stage. After testing the accuracy of your model, now we are going to use this model to make the prices of to make the prediction for the prices of Bitcoin. So here, what I did is I used the model, like they called the model to make the prediction for Bitcoin prices. So here at this stage, you remember we've splitted our data into test and train set, whereby now the test set is the actual values of Bitcoin, but we want to test if this model can be able to make the prediction for these prices that we split the for this now Bitcoin prices, because we've split our data into training and test set. So the test set is now you are going to test your model. Is it able to make the accurate prediction? So at this stage, I use the linear regression model to make prediction for Bitcoin prices. So here, what I did is I converted the when you import the data set into the linear regression, the method that is involved, the fit method, it converts the data set into form of arrays. So literally we are having our data set in form of arrays, but I converted the data to data frame, pandas data frame format, so that we could be able to see and compare the actual prices versus the predicted prices by the model. So here we have a pandas data frame that has 3 columns. So the linear regression model is able to make predictions for the actual prices of Bitcoin, Bitcoin actual prices. So the actual prices, you can see the first set for the first item in the pandas data frame. We have our model is, we can see our model is able to predict the first price as 8,435 when the actual price is 15,000. Like the index one is 512 by 330. So you can see, you can be able to compare the actual prices of this, the predicted prices with the actual prices. Yeah, so this is what the values that we are able to, can be able to get from the linear regression model that we train on our data set. Next, at this stage, now we are trying to make a visualization, a graphical view of what the model has done and the actual prices of Bitcoin. So I plotted the actual prices on a scatter plot. These are the green values are now the actual prices of Bitcoin against the predicted prices. So the predicted prices are the values that are predicted to be the Bitcoin prices for the next 2 weeks by the linear regression model. So you can see, you can be able to tell how accurate or how the performance of your model based on this. You can look at the actual price and you can see how close or how far the model is able to make the prediction for the Bitcoin prices for that particular day. So this is the graphical representation for this. Next, the second model is support vector machine. Support vector machine is one of the very good performing machine learning algorithms that can be used both for classification and regression problem. But in the case of regression problem, it has both, in the sklearn library, we have both support vector regression class and we have support vector classification class. Now that our problem is a regression problem, we'll be going to use support vector regression class. So basically, the support vector machine works in different formats. How it works, there is a function called kernel function. So we have linear kernel function for the linear data. We have polynomial kernel function. We have Gaussian kernel function, and we have sigmoid kernel function. So based on the kernel, on this kernel, okay, the kernel function now is like we said in linear regression, we are fitting this data to a straight line. In the support vector machine, what works is the kernel. So if it's polynomial, you cannot see the structure of polynomial. It forms some structures that along which the vectors are distributed. So this is fitted to that particular function, how the function works. So in this case, I tested both the polynomial kernel and the Gaussian kernel function. Sorry. Yes. So here, what you can see is for the polynomial support vector machine, the accuracy of this algorithm is 0.2. RBF here is radio basis function. Radio basis function is the kernel function that is used for Gaussian kernel function support vector machine. So the RBF model here, or RBF model, is able to make, after fitting the dataset, our dataset to this, it's able to make our prediction, and the accuracy of this model is at 90.92%. And finally, after fitting the model, after building your model and testing the accuracy of this model, we are going to use this model to make the prediction, the future prediction of Bitcoin. And that is the core of what the project is all about. So the same way, like in linear regression, I'm able to have all the predicted values on one column and the actual prices on the other column. So you can be able to see and compare what has the model predicted for this, what are the model predicted for this. So you can see for the first, the index one in our list here, it is 305 versus 330. So the actual price, when the actual price of the Bitcoin on that particular day is at 330, our model is able to make a prediction and it says it's at 305. Next, where at a point where our model make a prediction of 4023, the actual price is at 3735. So you can be able to compare and see the variance of these prices and see how closely as the model made a prediction for that, and see maybe if it works or it's far away, you could be able to see and infer. So this is how we've used the machine learning, the SVM model, to make the prediction for Bitcoin prices. And then finally, the same way, like we did for linear regression, I plotted the values, both for the predicted values and the actual values of Bitcoin on a graph. So you can see the graphical view of it, whereby now the scatter plot, the dot green, these are the actual prices of Bitcoin. And then I plotted graph against this according to how our model made a prediction for this. So you can see the actual prices plus the RDF predicted prices. Yeah. So you can tell from what you can see, but you can be able to tell if this model is closely ranging or performing poorly or good. So, but this is a visualization of how the prediction price values that are made by this machine learning algorithm and the actual prices. The next is embedded learning. First, what's an embedded learning is a kind of machine learning algorithm where you train multiple learners and then finally you combine the results by these different multiple learners to make one final composite learner. So the embedded learning categorically are divided into what we call bugging and boosting, whereby when you talk of bugging, you train multiple learners differently, and then you add all the results to be the final value of the final model. So it's like in real life, you can talk of, maybe you ask a question to a group of people, and then you summarize all their answers and come up with one summarized answer. And then compare this with an expert answer that you get from an expert. So it's always believed that a summarized answer from different random people is much better than one expert answer that you get. So this is the wisdom of the masses. There's always the wisdom of the masses that exists. So the embedded learning method literally borrows from this concept, whereby multiple learners are trained and then you acquire the results from all of this and then come up with a composite learner that gets an average for all this. And then there is bugging and there is boosting to embedded learning. Boosting is a case whereby you build model upon each other, whereby the first model is built on the second model is built on the first model, and it's trying to reduce, as you continue building up, you are trying to reduce the residual bias, the bias of between, that is when I say bias, the difference between the actual and the predicted values. So as this model make a prediction, definitely it doesn't get something close to accurate one. So the next model is built on this to reduce the bias. So as you build more and more model, finally you will come up with the final model with the least bias, like with the least error. So that is how embedded learning are divided into bugging and boosting. So an example of a boosting is like random forest is one of the boosting, embedded learning, and bagging. Boosting is many others like ADA boost, XG boost, GDBT, and many others. So for this case, I used random forest, which is a bagging form of embedded learning. Random forest, as I explained what bagging embedded learning is where you build multiple decision trees and merge them together to make one more accurate and stable composite learner model. So a random forest can be used for both classification and regression problems, just like SVM. So using the very, very same data set, I'm trying to build this model upon the same data set. So here it is. The random forest model is at 87.54. So using the same data set, when I build this random forest on that data set and try to test the accuracy of this model, I was able to acquire an accuracy model of 87.54 for the random forest. So you see, compared to the linear SVM and this one, you can see this is more than linear regression, performs better than linear regression, and quite below support vector machine. So at the same time, I was also making a prediction for a random forest. So whereby I was making a prediction for particular, here you see this line here, I was trying to make a prediction for the first item, the first index, for the first index, what is the predicted price for the first index of the test values. Remember, when we split our data into the test value, after training our data, we are trying to make a prediction for the data set that we already have set aside a particular set of data just for test to test if your model is able to make a prediction that is close to this or anything close to that in comparison with the test values. So you can see our random forest is able to make one of the prediction as 277 when the actual value was 330. And as just like the others, I was able to make a plot prediction for this, whereby I plotted a graph of the actual prices against the predicted prices. So that is that. So as we continue, here at this stage, now I am now that this is where the forecasting, using this model to make future prediction prices now comes in. I've trained 3 models, and then you've seen the accuracy of this model. Now we have the data set for the past 5 years, from 2016 to 2020. So I'm trying to test my model, to use this model to make future prediction of Bitcoin prices, let's say for the next 1 month now. So based on the last 30 elements of my data set, I managed to make a future prediction of Bitcoin prices for the next 30 months, that is in 2021, let's say the January of 2021. That is what I did here from some date in December 2020. So here, when you see this, I just predicted the last 5, I just displayed the last 5 items. What I did here is now I used my model to make the future prediction of Bitcoin prices in the next 30 days. That is why we do not have any values for average, close, high, low, and open. There is a new column here called prediction. So this is entirely the predicted prices of Bitcoin on these dates. Remember, in our data set, we do not have these values, December 29, 30th, 31st, up to 20. We don't have all these values. So these are the days that now I wanted to make a prediction of Bitcoin prices. So using the data that model that I have trained, I was able to make a future prediction of Bitcoin prices, and I incorporated a new column called prediction, whereby the values for the predicted price is as displayed here. So you see the next 30 days price prediction here. So this prediction column entirely contains 30 days prediction. The next 30 days, that is from the last observation in our data set. If, for instance, the last observation was on 18th of December 2020, our prediction is from 19th of December 2020, the next 30 days. And that is what the values that we have in our prediction column of our pandas data frame. So after making that prediction now, I join these now, the predicted values on our existing Bitcoin close prices. Remember, we have a feature, a column in our data set where we are having the closing prices of Bitcoin for the last 5 months. So this price range, the values in green are the close prices of Bitcoin from 2016 to 2018, up until when we collected the data. So I have used one of my models to make future prediction of these prices from that date, 30 more days. So the values in yellow are the values predicted by our model. It's not the actual prices that are the actual prices that we pulled from our data set. So from 2016 to 2020, anything that is in green is the Bitcoin close prices for the last 5 years. So after we have trained our model, our machine learning algorithm on this data learning algorithm,
Did we lose Ibra? Can you guys hear me?
Yeah, I can hear you. Looks like we lost him.
Oh.
Yeah. Hopefully it's gonna jump back in. Let's give it a few minutes.
You know, I want to see how he'll be you see how his head is cut off now?
Yeah.
I don't know about that Saturday, whether we need to meet a little early so that he's I want to see that space. I don't want, you know, to be there, but his presentation is absolutely amazing. Like, we really lost him.
Yeah, it's gone.
Is he going to be able to get that office space before Saturday?
I'm not really sure, because I had just heard him talking about it today.
Let's ask him. So, you know, it would be nice to just do a trial. You know what I mean?
Yeah.
In that space, we can create some time before. But me, God, let me tell you, you know, the good thing about me being not a Python person, and I know I'll get there one day.
Yeah.
But you guys, you know, these are things that are basic to you. Do you understand? So it's like guys go deep, but I'm looking at it from a layman.
Yeah.
And he drew me in. I'm like, hey, so you mean, so his presentation, like the world, you know, now if he does it like, you know, clear face and everything he is so good. Because I'm actually following and I'm like, oh, okay. I see where he's going with these words.
Yeah.
It is amazing.
Yeah. He's done a good job on that.
Oh my God, he is so good. And the beauty, another thing that we need to pump him up, because I was even pumping in an investment club. I was like, you guys need to come for this. This guy's talking crypto, and everything.
Yeah.
And some guys who, you know them from Tech Tips and Tricks. And I was like, this is amazing. And remember, for a lot of our classes, we didn't have men. It was women. So the beauty is Ibrea, and then it's Moyale Kenya, and it's a guy. Like, we really have to pump. This is such a good, he's an outlier. When he talked about outliers in the thing, he is the outlier. He is, you know.
Yeah, he's the one who stands out very, way out there.
Oh, this is, Annie, I'm so happy.
Yeah.
My heart is so happy for he has done it. Yeah. And then being able to break it down to people who don't understand Python, I'm like, hey, maybe I can learn this thing.
Yeah, the guy is good.
Wow.
The guy is good, yeah. He's really done a good job.
Okay.
By the
so
time,
I guess,
by the time
do you want to stop recording?
Huh?
Do you want to stop recording or you'll cut this? I don't know.
Let me go ahead and stop for now.
And I stated the beauty about this is with me being an outsider, this is not my line of work. It's not what I do. It's not what I've studied. So looking at it from that eye, I followed your entire presentation. I got your thought process. I got what you were trying to do. And it also got me interested. I'm like, maybe I can actually learn and understand it, because the perception out there in the world is like, this data science is complicated, Python is complicated, getting things to work practically is complicated. But how you've presented it makes it, I can swallow this, I can bite it, I can swallow it, I understand what you're using it for. I love the topic that you picked up, cryptocurrency, because it is a big deal. You know, the world is really looking to understand it better. So how you broke everything down, Ibrea, is absolutely amazing. You're great at your message, you're great at your presentation. So I can't, other than the electricity going, and I would really like to make sure that we see your entire face during the presentation. So see how your head is cut off right now. I'm just seeing like this part, like your forehead, you know.
Yeah, we only see half of you, man.
Right. So it would be, so I would really like for us to create time to go over this one more time, just so we can figure out from a timing perspective, how does that look like from a clear presentation perspective, how my introduction will be. I went over some stuff with Migot, training to get you from introductory to get you here. What does that look like? What have the past statistics told us? You know, how does that look like? And then you, Ibrea, you're an outlier in your presentation. You talked about being an outlier in the data, but you're an outlier in the outcome because one, you're in Moyale, Kenya. Two, you're a male. That's not the statistics we had before. So you being the first one and you're ready and your presentation is absolutely amazing. Oh, we have to sing your praises, you know, then we have to keep pushing that because what you've done is absolutely amazing. And then for you, from building your brand perspective in data science and in Python, you need to keep running with this story, you know, the outlier in this case. Remember, you're in Moyale, Kenya. That means it shows that the amount of effort you put, because there are many people sitting in Atlanta or sitting in Texas, sitting in Nairobi, and whatever the case may be. And then it seems like a lot of men, for some reason, have started losing focus in like tech subjects. It seems like a lot more women are putting in the effort. So to see you as a man coming out, so that's the thing that you have to also remember. And the thing that you're sitting in Moyale, use it for you so that you're entering the doors where people need you in. And then crypto is so right now. So keep driving this narrative, even as you go into whatever. Make sure that the talk that you gave today is part of the things that you add on your resume so that crypto is also standing out, that you are understanding how to use data science, cryptocurrency. Those things are a really, really big deal. I'm going to send you, actually, Migot, remember the guy I told you who I met on the Kipna chat?
Yeah, Dr. Sanso.
Right. And because he is driving and he's very enthusiastic about crypto, I really think he needs to meet Ibrea because that is also a man. You know, you guys men are losing out on this thing, right? We're losing you, Black men. We're losing you, Kenyan men. We're losing you. So that momentum, it needs to come together. So Migot, I actually think after we're done with Ibrea's talk, we need to partner with this guy who's leading the T-Mobile and Ibrea and you three, and then come back, even if it's on a Tech Talks fireside chat, let's get you guys talking. You understand? The three of you talking data science, talking crypto, get that conversation going because he leads a team at T-Mobile. You never know what opportunities he can open up and you never know what opportunities Ibrea can open up. You know, it's the telephone. M-Pesa is a big deal. You just never know what that conversation can stir up.
Yeah, that's true.
And in terms of training, you never know which people will be pointed you in a direction because they need that education.
I agree.
Okay, so great job. And you and I will touch base on the back in regards to that other talk that the three of you need to do. So I'll take it in my notes too. Ibrea?
You did good, man.
Yeah.
Jackie, when do you think we can meet again with Ibrea before? Because the final day for his presentation is going to be next week.
Saturday, yes. Do you want us to meet on Friday or which day? I mean, I'm okay. I'm okay with whichever day you guys tell me.
Friday would be great. Ibrea, can you make it on a Friday?
Wednesday.
Huh?
Okay. I thought of maybe Wednesday, maybe so that I'll be able to add or incorporate the changes, or maybe a comment what you would think I need to add or what you think maybe I need to.
That's okay. If we don't have the time, that's okay too. That's absolutely fine.
Did you say Wednesday?
He requested Wednesday. Do you have time?
Yes, Wednesday.
Okay, Wednesday, what time, Ibrea? Because Wednesday we all work.
A time like this?
Wednesday, a time like this. might be very challenging.
It's what time is it?
It's
Yeah.
3 o'clock.
Then we can
Because
work with Friday.
do you have a lunch break somewhere on Wednesday or no? I can also just pull up my calendar and look. Your work day is crazy.
What my work day is crazy on a Wednesday. That can take 1 hour.
I think Friday we can we settle for Friday then?
Yeah, let's settle for Friday.
Friday.
Friday,
Okay.
Friday what
sorry,
time?
Definitely a time like today.
let me look at my calendar.
Because
Nigot,
from
do you have lunch on Friday? Do you have a lunch break on Friday?
I can take off on Friday. Then just be
Let me look at my calendar. 1 second.
okay. So how do you feel? You feel ready?
Yeah, I'm ready.
Okay, cool.
Maybe unless maybe you have something to add, maybe to comments that you think I need to incorporate.
My Friday,
Yeah.
my calendar isn't, I mean, I'm not off for the day, but my calendar doesn't have any appointments right now. So what time works?
Okay. So Ibrea, what's gonna be your best time on Friday? Around
I
this
can
time?
be available. I think it's you to yeah.
Okay, normally
Around this time, well and fine.
okay. Because around this time on Friday, I can make it I can be available for 1 hour.
Tell me the hour so I block my calendar. Should we start like at 2 p.m.?
We can start at 2 p.m. on Central.
So that's 1 p.m. 2 p.m. Central. I work on Central time, but I live in Eastern time. I just need to block the calendar so that no one else takes that time.
Okay.
So do you want to do 2 p.m. Central?
Yeah, let's do 2 p.m. Central on Friday.
Okay, let me block my calendar.
Yeah, Central. Because I have a mandatory meeting every 3:45 every day.
Okay.
Change management.
Okay.
Yeah.
Okay. I've blocked 2 to 3.
Okay, 2 to 3 sounds good.
Yeah.
Yeah. Is that
Esther,
good?
did you fall asleep? Esther.
Yeah.
Esther fell asleep, maybe.
Esther, you there?
No, I didn't.
Oh, why are you not saying anything? Your opinion matters.
I'm actually learning from what Ibrea is doing because it's almost similar to what I'm currently working on. Yeah. So it's really good. I've actually like learned from the presentation.
That's great. That's great.
Esther, you're gonna have to pay Ibrea some money.
Yeah.
Yeah.
Yeah,
Ibrea did a
we'll
good
talk.
job.
But you know you're still
Yeah.
recording this part. Do you want to record this part or no?
It's being recorded now.
Okay.
Yeah.
No, I guess the one that we're gonna put up on the YouTube for real is the
Oh, no,
one.
it's the final one.
I got you. I
Yeah,
got you.
on Saturday. Yeah. This
Yeah. Yes.
Yeah. You're gonna have to come to that room you're talking about, Ibrea, and then we'll have to see your face. It's
Okay.
gotta be like up to your chest at least.
Mhm.
And then you share your screen and you talk loud. Today you did very well. Yeah.
And then Ibra, let's look at your lighting because you are dark skinned. You have to pay attention to that. In the where you are right now, you're fading into the background. You know what I mean? Like, see, I'm not. You can see my face. I can see me God's, but yours. But I don't know. It may be that on Saturday the lighting may be different.
Yeah.
So let's just make sure that people can also see your facial features and all that good stuff because your content is beautiful. Now we want to see the person who's presenting this beautiful person. There you go.
That's right.
Mm-hmm.
So
and your face is beautiful. We want to see your beautiful face too.
Yeah. So Ibrea, did you say you're gonna be in a different place, like in an office environment?
Yeah, I'll be in a different place.
Okay, can you be there on Friday? I mean,
Yeah.
when we're doing this
Yeah,
on
we can be
Friday.
there on Friday.
Okay.
Okay.
So we
Yeah,
can
we can do the rehearsal on Friday.
Okay, cool.
Okay, great.
Yeah, we want you to be the
Approximately
best.
how long did we take? We took around an hour. Your presentation is approximately what, 45 minutes to an hour?
It's gonna be 1 hour, but Ibrea, you'll have to make sure that we do it for 1 hour, but about 50 minutes so that we can leave 10 minutes for just in case of any questions.
Yeah.
And actually on the same maybe from my presentation and how I may be explaining things, definitely maybe there are things that you thought maybe I don't need to go much into. So you could pinpoint or tell me maybe the things that I should just explain to this point and continue with it. Yeah, so those are actually the kind of comments I was asking.
Yeah, so I will let you know on Friday. The places where you don't like, we don't need it to be too technical, but just give an overview. Yeah. Like, for example, the supported and supported models. And your code, you don't have to explain the code examples. It's almost like you're showing your CEOs, okay? They don't care about the programming, they just care about what is it in there for them. They look at the bottom line. So in terms of money, how can you convince them to fund your project, for example? So that's what we're going to be looking for. But we'll point those out for you, so you can compress it to about 50 minutes at least.
Okay.
Okay.
And Ibra, always feel free. Like you see, your presentation is absolutely beautiful to me as a layman, right? So if you feel that you ever want to talk about your code deeper, so get to that part of the presentation, right? And then you can record outside of that, not necessarily for the people here. But if you feel, oh, I want to talk about my code, this is what I want. It's now your own promotion. Get to that part and say, on this part during my talk, blah, blah, blah. Run with this talk like forever. And if anyone is interested to know the code involved in this part, do a 5, 10, 20-minute video specific on your thought process behind your code, how you built it, how you came up with that. And it doesn't mean it doesn't have to be only one. This is the presentation you're giving to the world. That's fine. But I'm sure Mio and Migot can still give you a platform if you want to go deep into your code. By all means, go deep into your code. For now, me and Migot, we can still plan and say, okay, different audience, and this is how he thought about this. Yeah. Let's create a platform. Let's listen to you too.
That's a good idea. What do you think about it, Brea? Is that something you probably want to do?
Nice.
After the main event, you want to go like really technical so that you explain your code to the people without giving away your code. Okay. All right.
Yeah, that's nice too.
And those are good things, like you can also put on your LinkedIn. You see, for a recruiter, like if you give us that talk, and then that talk when you're going technical you can do the overall talk if you want to put on LinkedIn by all means, but then for the code, the breakdown, giving it without really giving it, put it on your LinkedIn. So a recruiter is like, okay, I want to know more about this. An employee is like, okay, he seems like he knows what he's talking about. Let's, so yes. That's for your marketing purposes too.
Exactly. It's going to be a big deal, man. Mm-hmm. I'm surprised, man. You learned a lot within that short time.
Keep hitting that crypto talk. By the way, we have to make sure also Idris comes for this talk and stuff like that, and Sophie and everybody, they get to see this beauty.
Yeah. Mm-hmm. Yeah.
Ibra, nice. Your homework classes need to come. Your homework people need to be at the top cheering you on.
Yeah, you're gonna invite people from like your family members too.
Yeah. There are some friends of mine who say they will be attending. So yeah, I'll be having a few of them.
Invite your schoolmates and your college mates and everybody who you want to invite.
Yes.
It's gonna be a big day, almost your graduation day, man.
It is his graduation day, actually.
Yeah. This is big deal.
Ibra, what is your address in Moyale? We want to gift you with something. Migot and myself and Esther, we are so proud of you. How can we get something to you?
Oh, we Moyale, yes, it's in Moyale town, so I stay
Can you
in
tell me how we can reach
the
something to
customs.
you?
Here they call it
You're gonna
customs.
put PO box in the group.
I will reach out
But
to you.
the PO box will
I
have
will
to go.
reach out to you. I will text.
Something cannot be delivered to you to a shop or to where you stay.
Yeah, where it can be delivered.
Yeah,
It
tell
can
us
be.
somewhere we can
Right.
deliver something for you.
If it was to come by via DHL, how does it come to you?
There is a means. We have a poster here. We have there are a number of means. So I think I will text you.
Send me something, yeah, where we
I'll
can
give you
deliver
some details.
something.
Okay, cool. Look forward to that, man.
Mhm.
All right.
You did very well. Thank you.
Very, very.
Here, Esther says she stole some of your ideas, so we're gonna look out.
I didn't feel, but I gained insight.
We're all a team here. It's okay.
Yeah. Yeah, I actually was wondering whether the presentation that you should explain how you cleaned the data and did the pre-processing. So that was one thing I was wondering, from his presentation, I didn't think about that.
You didn't talk about that?
He did, but I didn't think we needed to talk about it.
Oh yeah, that could be probably too technical. You can leave that for the very technical audience.
And I actually think we need to start Migot presenting to the technical audience so that they are very comfortable talking about their technical skills too. You know what I mean?
Yeah.
So I think we should still push that, even if it's amongst us, like the homework group, the Python people, advanced Python, and whomever else in Kipna Tech, whatever. We invite everybody, so whoever wants to come. But the aim will be just to get the students very comfortable talking for 30 minutes about their codes, so that by the time they get to the interviews, it is not something they're doing the first time. They've done it 10, 15 times. It's just regular.
Yes.
Okay.
That's exactly correct.
Mm-hmm. So Esther will be looking forward to your presentation on the technical part. Kwanza, even Esther hasn't given her presentation on the something. I've only seen Monica and Lucy. Esther, when is your talk?
We are going to do it. We are a group.
So it's coming up soon.
Esther's group is dead on arrival.
But Esther is not talking nicely. Esther ujambiwa poa.
It's good to prove people wrong.
Ibrea and Joseph, I thought those were the dead on arrival group. Kumbia was wrong.
He cannot talk to you like this. You have to prove him wrong, man.
I know Esther and that group, they're grinding. So
Esther, you have to come out guns blazing. He cannot talk to you like this and then you just sit down and you just accept.
I can't accept that. Yeah.
You have to show him over here.
Yep.
Okay.
By the way, they face a lot of my meanness. This time around, I've been so
You were not playing with people. Migot was tired.
I'm the only one who faces all that.
Exactly. They still come with a lot of Kenyan mentality to the fore. So man, you can't bring that over here.
and that's a good, very good concept, Esther and Ibrea, because the world is opening up, and then the talent is not enough, just let's say in Europe, in the United States. So when Migot is giving you all this hardcore stuff and he's telling you what time we need to meet, that's because you'll be working for the United States anyway. And these are the audiences you'll be meeting anyway. So the earlier you train, the better. And also when you look for these jobs, yes, you can look for them in the 254, which is fine. But remember to also get into the websites. There's the Deloitte and Touches. There's the KPMG, EY. Look for the jobs that offer sponsorship. So all this, they're not enough technical people to fill these positions. So when you're looking for work, do not only focus Kenya. Focus on the world. Put
Yeah.
your skills, what comes up. And then if you see, oh, it's a company in the States, don't be threatened. Go inside that job and look and
That's
see if
right.
they offer sponsorship. And then even if sometimes they don't offer sponsorship, but the skills are very technical and you can hit all of them,
Yeah.
send your resume anyway. You understand? If they call you, prove that you're the only one who can do that job. They will most probably look to find a way in which to employ you. The skill set is not enough. It's just not.
Exactly.
Mhm.
Don't second guess yourself. Just put it out there and let them decide. If it goes, it goes. If it doesn't, that's fine too. Nobody will come kill you.
And you see what I've also noticed, Migot, and I really pay attention. And I really pay attention to also the people already living in the United States. Some people have been like, you guys, we do take, someone is like, I'm comfortable in my job. Always remember when people are comfortable, and I find that people who are already in the States, whatever, they'll be like, they're okay, there's money, there's whatever they're making, there's something.
Yeah.
A lot of the time I pay attention to when Migot is giving classes, who is actually focused, who's something. I find a lot of people in Kenya are the ones who are really delivering. You guys, think about it. If people are not learning Python and data science now,
Yeah.
even if there's no job today in the United States, think about who is always showing up for classes, even based on Ibra's data science and analytics and all the things that she's doing. There'll be a time, if the people sitting in the United States are not learning, there'll be a time for real, you look at something. They'll say, we want to hire from the state. You tell them, okay, hire. Who do you have?
Yeah.
No one. Pay attention to the students you go to class with. If it is only the people in Kenya putting in work, give it 2 years. There'll be a time they will be unable to hire from the States. Why? Because guys sitting in the States are comfortable. They haven't put time to learn. So they don't know people with crypto, with data science. They will have no choice but to hire you. The day they have a choice, no choice but to hire you, be ready.
Yes.
And at that point, you may be able to do 2-3 jobs, because when there's no talent, there's no talent. Now you're the one with all the talent. Who says you must do 1 job? You can do 2. You can do 3. If you can do it, do it.
Yeah. Right now, a lot of companies are hiring, so it might just be one of those they're looking for.
Mm-hmm.
Yeah. You might say, well, we don't normally do this, but we're going to do it for you today.
Put people in the hotspot. How many nurses do they import all the time?
They do.
Have you seen companies for nurses, healthcare? They don't have nurses. You will get your green card, chop. People didn't want to study nursing. There's a shortage. Yeah. Same thing with cybersecurity. Oh, we only hire Americans. Okay, you show me the Americans who can do this job. Okay, we can do your paperwork. They are going to find a way to make it work. Here is your green card. Here is your American citizenship. Because they need to fill those spaces. How can you have a country that is not secure? Cybersecurity is growing.
Exactly.
Mm-hmm. Python and this data science and all this machine learning, crypto, it is the next thing over here coming. At some point, it will not be hard for you to get your paperwork, because if you have to be American, they will make you American. You know how America is; they do whatever they want to do.
Yeah, America is ahead. They decide.
Mm-hmm.
Yeah, they do. Yep.
Thank you for the information. We'll definitely work towards.
Yes, but Esther, another thing that you must do is you must brand. You must brand. And I'll tell you, my example is I'm not deep into cybersecurity. I am in SAP security and GRC, not hardcore deep, but I've been hanging out and working with the cybersecurity folks sana. So getting in. But get what I'm doing. I'm doing a talk in Kenya, to SheHacks Kenya, on cybersecurity, and I was able to get the panel and pull the people along so they get across the board how to get into cybersecurity branding. But that's because I branded myself. So that's how I got the opportunities. So you must come out and talk so that someone is like, hey, cryptocurrency, data science, machine learning. That has to be Ibra's name on it. Kapsa. So when people start talking to Esther, what is your brand? When I see you, what do I think? What do I know? What do we even know now? I mean, I know you're good because I look for you to know that you're good. I'm sitting in Migot's advanced science class. But does the world know how good you are? I know in the summer camp, you're good because you're an instructor and you teach very well. But do you actually self-promote? That people know, oh, if I need my kids to learn this, data science is this, when I see you, what do I think? Why should I look for you?
Yes, that's exactly correct.
Mm-hmm.
Mm-hmm.
Yeah.
There are
Think about that. Yeah.
No one is coming to save us. We have to definitely save ourselves, but we can and we will.
Something we have to do.
Yeah, I'll definitely like work on that. I'm still figuring my my voice and my footing in the tech world.
Huh?
And I'll tell you,
Huh?
don't wait too late. And when I say don't wait too late, like figure it out, but actually also go ahead and do it, Esther, because sometimes also in life you're given a gap and a window. Like I'll say, with the D&I issues after George Floyd's murder, the world started listening to Black people and what they had to say after a very long time.
Yes,
a lot of people were promoted to CEOs in the D&I space. A lot of Black people were given opportunities in various spaces because the world was in uproar about the inequality. But remember, the world doesn't wait. There's something new that is going to happen. So if you do not take advantage, it's in uproar now. You want to be CEO. This is the time. Fight. Umefika, sit in that boardroom and then in the decision-making table. But you wait 5 years. You think they'll care 5 years? I mean, something else will have come up. It will be crypto. It will be Ibrea. Everything is crypto. Oh, put Ibrea in. And then your thing, which you aren't sure about, it has passed. Now you're like, oh, Jackie, I'm a Black female in tech. I said, those ones, they were catered to 5 years ago. You have come here. It's crypto now. If you're not talking crypto, people don't care. So you move with what is also working for you.
I agree.
Okay.
Okay. Hey, Esther, don't just say okay. Do something about it.
Yes, I will. I will.
Yeah, I want to receive a phone call from Germany. Okay. Hey, by the way, I got hired last week. So we know at that time we have somebody in Germany now.
Yeah.
Don't short sell yourself.
Those opportunities are there and they're available, but you have to make them for yourself.
You have to.
Let me tell you, let me give you an example, Esther and Ibrea and Migot. So there was a time in Kenya, what was it? I think it was Citizen, was it KTN? One of them anyway called. They thought I was in Kenya. They're like, oh, we're doing Africa Day. We want to invite you. This, can you come to the studio? I said, oh, I'm in Atlanta. They said, oh, then let's get somebody on the ground. I said, TV. I said, let me tell you something. No one can do that interview like me. I have to be the one. Let me explain to you. It has to be just me. It is me. I am the only one who will give you what you need. Somebody no. I'm not giving my opportunity. Hey, you need me. Okay, yes, I am here. I said, listen, let's do it virtual. Let me explain. They had not done, but they were worried. They're like, but it's going to be live TV. Let me tell you this, the other. I convinced those people. I said, I am the one. I will give you the energy. I'll give you the power. I'll give you the oomph. I'm going to make it pop.
You're one and the only one. Yes.
I am the only one. Please do not give me opportunity, because of course somebody else could have done it. But I am not even letting you get off the phone. Before you come up, me too. Stay. I said, this is how we are doing it. I want to do my makeup. Let me tell you. And then they delayed the call. I was 2 a.m. ready. Do you know I did that interview at 3 a.m.? I had sat up in my makeup and I was ready, and I have to find that video. But when I hit that stage, even then, they're like, hey, Jackie's calling from America. I said, I know, you also look nice yourself. See, I called in, it came out nice. I'm over there, I've decided Africa Day. All of us benefited. You look good, you can do this. Even when I look good, I'm the only one who can. It's not we're the only ones, but you sell that thing. When you show up, it has to be you, and then you bring the power punch like madness. But we all won. All won on that day. So even you, Ibrea, when you come on Sato, you come in and bring Ibra's come, and then boom. But we have to see your face. You take over that stage. Guys are like, oh, Ibrea. They have to. Esther Meskia.
Yeah, I've heard.
There you go. I guess we'll say bye now, Cindy. We got his on call from Germany saying Esther got the job. So I guess Esther, what time is it now there, Ibrea?
It's almost midnight.
It's almost midnight?
11.
Oh, 11. Okay.
Yeah.
Okay. I guess we'll say bye and then we meet. Esther, are you going to be able to make Friday?
Yeah, I will. And
Migot will send us the link, and then we do it again. So Ibrea,
you're going to use the same link Friday.
Okay.
Yeah, I'll resend it.
Okay. So I'll see you guys Friday. And Ibra, great work. Just power pack it. And your face is very beautiful. So also use, I mean, humans, they are very visual as well.
Exactly.
So show off your beautiful face.
I know you forgot the lipstick, but on Friday, don't forget that. Okay?
His teeth are very beautiful.
Okay,
His features are very beautiful.
Yeah. Very nice.
So we use everything.
Okay. I think we're good then.
Okay.
All
I
right.
will say goodbye. I want to say real quick. My mom called me in the middle of the call. I want to say a real quick hello to her. Ibra, I want to brag to my mother about you. I'll tell her also about Esther. And then I need to go to the gym. And then after that, come back and do some work.
Yes. Thank you so much, Jackie, for
Thank you very much.
taking the time.
Absolutely.
Thank you so much.
Esther, thanks.
Thank you.
And then you
Thank
guys remember the technical talks. Let's not forget that in the process.
Yes.
We will revisit.
We're gonna do it.
Okay, God bless.
God bless
Bye.
you.
Yeah, okay.
Thank you.
Bye.
Thank you guys for
Bye.
coming. Okay.
Bye.
Yeah, yeah.